Today we are treating the last type of fraction, and that is improper fraction. So let's take an example quickly. First of all, let's talk about what an improper fraction is. When the degree of the numerator of a fraction is equal to or greater than the degree of the denominator of that fraction, then the fraction is called an improper fraction. So if the degree of the numerator is 2 and that of the denominator is also 2 or less than 2, then the fraction is an improper fraction. I say that again. If the degree of the numerator of a fraction is the same as the degree of the denominator of that fraction or greater than the degree of the denominator, that fraction is an improper fraction. So we see how to resolve improper fractions into partial fraction. What we do is divide the numerator by the denominator to get a quotient and a proper fraction, and then split the proper fraction into partial fractions. So let's take a few examples on that. First, I write that D. We started naming them from A. So this is the fourth one, and that which is D. Improper fractions. Improper fractions. Example: resolve into partial fractions. Resolve into partial fractions. Roman figure 1. X cubed plus 2x squared minus 2x plus 2 over x minus 1 times x plus 3. Let's take all the questions before we begin to solve. Roman figure 2, which is the second example we are going to take. X raised to the power 4 plus 3x minus 1 divided by x plus 2 times x minus 1 squared. And the last one, Roman figure 3, x raised to the power 3 x raised to the power 3 plus, I think I'm going to take a different one, 2x raised to the power 4 minus 17x minus 1 divided by x minus 2 times x squared plus 5. So these are the three questions we're taking as examples. Now, let's see how they are resolved into partial fractions. The first one is x raised to the power 3 plus 2x squared minus 2x plus 2 divided by x minus 1 times x plus 3. We can see that if the denominator, if the brackets in the denominator are removed, the polynomial that's going to be obtained will have a degree that is less than that of the numerator. The degree of the results is going to be 2, which is less than the degree 3 that the numerator has. So that means this is an improper fraction. If you multiply the denominators, this is going to give us something like x squared plus 3x minus x minus 3, which is the same as x squared plus 2x minus 3. And we can see that the degree that it has is the power of v, is the highest index in it. That means it's a polynomial of degree 2. And the numerator has a denominator has degree 3. The numerator has degree 3. So the fraction is an improper fraction. So the first thing to do is to divide the numerator by the denominator. So I want to write this as x raised to power 3 plus 2x squared minus 2x plus 2 divided by x squared plus 2x minus 3. Now I want to divide that. So how do I divide? X raised to power 3 plus 2x squared minus 2x plus 2 divided by x squared plus 2x minus 3. So we just divide, normally as we divide polynomials. That's easy. X cubed divided by x squared is x. Whenever you divide, you multiply the whole of the dividend of the divisor by that result. So x times x squared times x, that's x cubed, plus 2x times x, that's 2x squared, minus 3 times x is minus 3x squared. Now I subtract x squared minus x squared, that's 0. 2x squared minus 2x squared is 0. Minus 2x minus 3x, that's minus 2x plus 3x, which is x. Now I bring down the next term, which is 2. So x squared in x squared will not divide x. So the fraction becomes, so that means x cubed plus 2x squared x cubed plus 2x squared minus 2x plus 2 is the same as minus 2x plus 2 over x squared plus 2x minus 3 is equal to x plus 2 divided by x squared plus 2x minus 3. It's important to note how the proper fraction is obtained. When you divide, then you just write the quotient and add the ratio remainder to divisor, which is going to be a proper fraction. I say that again. After the division, you write the quotient and add the ratio formed by the ratio. You add the fraction, which is a ratio remainder to divisor. The remainder here is x plus 2, while the divisor is x squared plus 2x minus 3. So the ratio remainder to divisor, which is x plus 2 over x squared plus 2x minus 3, is what gives us the proper fraction. Then we split that proper fraction into partial fractions. And we add the partial fractions to this quotient x, which gives us the partial fractions into which the compound fraction is broken. So I now have a proper fraction, which is what I'm splitting into partial fractions. That's x plus 2 divided by x squared plus 2x minus 3. And I know that that denominator is a product of x minus 1 and x plus 3. So I'm just going to rewrite it as that so that we can split easily into partial fractions. X minus 1 times x plus 3. That's what x squared plus 2x minus 3 splits into or factorizes into. So now this means a over x minus 1 plus b over x plus 3, which is the LCM is x minus 1 times x plus 3, and that's the numerator of that fraction will be a times x plus 3 plus b times x minus 1. So what that simply means is that since the denominators are the same, that means the numerators are also equivalent. X plus 2 is equivalent to a times x plus 3 plus b times x minus 1. Now what do? Let me I can solve for the unknowns simply by the cover-up method. So putting x equals minus 3 plus 2 is equal to a times minus 3 plus 3 plus b times minus 3 minus 1. And that means minus 3 plus 3 is 0, which means the whole of this is 0. So I have minus 1 equals minus 4b, which simply means b is equal to 1 over 4. Now, what do I put in the identity to get the second constant? Putting x equals 1. Putting x equals 1. 1 plus 2. 1 plus 2 equals a times 1 plus 3 plus b times 1 minus 1. 1 minus 1 is 0. That means the whole of this is 0. And we have 3 equals 4b, which means b is equal to 3 over 4. So, therefore, the fraction x plus 2 divided by x minus 1 times x plus 3 splits into x plus 2 divided by x minus 1 times x plus 3 splits into a, which is 3 over 4, divided by no, a is 1 over 4. A, which is what did I do here? It's supposed to be a. B is out, so that's 3 equals 4a. And a is what is equal to 3 over 4. So sorry about that. A is 3 over 4 all over x minus 1 plus b, which is 1 over 4 over x plus 3. And this is the same as 3 over 4 times x minus 1 plus 1 over 4 times x plus 3. So we have split the proper fraction. Then we can have the partial fractions into which the original compound fraction is split. The original compound fraction is x cubed. That means x cubed plus 2x squared minus 2x plus 2 divided by x minus 1 times x plus 3, which gave x plus 2 over x minus 1 times x plus 3 when we divided the numerator by the denominator, and that's the same as x plus 3 over 4 times x minus 1 plus 1 over 4 times x plus 3. And that's it simply. So we go quickly to the second example from our figure 2. That's let me check what from our figure 2 is. From our figure 2 is x raised to the power 4 plus 3x minus 1 over x plus 2 times x minus 1 squared. That's from our figure 2, x raised to the power 4 plus 3x minus 1 divided by x plus 2 times x minus 1 squared. We would say that if we split this, if we split the denominator, it's going to have a degree that is less than that of the numerator. Let's check that. X plus 2 times x minus 1 squared. X minus 1 squared is the same as x squared minus 2x plus 1. And if we further split this, we are going to have x cubed minus 2x squared plus x plus 2x squared plus 2x squared minus 4x plus 2, and this gives x cubed plus 2x squared cancels plus 2x squared, x cubed plus x. Okay, x minus 4x is minus 3x plus 2. That's what that gives. X cubed minus 3x plus 2. And we can say that its degree, which is 3, is less than the degree of the numerator, which is 4. So that means the fraction is an improper fraction. The fraction is an improper fraction. So the first thing to do is to divide the numerator by the denominator. And let me write this. Write this as x raised to the power 4 plus 3x minus 1 divided by x cubed minus 3x plus 2. We have to be sure, but that's what we got. X plus 2 times x minus 1 squared is same as x squared minus 2x plus 1. And this gives x cubed minus 2x squared plus x plus 2x squared minus 4x plus 2. Minus 2x squared plus 2x squared is 0. And that's x cubed minus x minus 4x is minus 3x plus 2. So that's correct. The denominator becomes x cubed minus 3x plus 2 when it is expanded. So now I can divide the numerator by the denominator just to reduce the fraction to a proper fraction. That means x raised to the power 4. I want to write the terms that do not exist. So instead of leaving the space blank for the x cubed term, I'm going to write 0x cubed plus 0x squared. This is just to make it clearer when we divide, plus 3x minus 1. And the divisor is x cubed minus 3x plus 2. So x raised to the power 4 divided by x raised to the power 3 is x. And we multiply as usual. X raised to the power 3 times x is x raised to the power 4 minus 3x squared plus minus 3x cubed plus 2 x raised to the power 4 minus 3x squared. We are multiplying this divisor by the x. That's x raised to the power 4 minus 3x squared minus 3x squared plus 2x. So minus 3x squared plus 2x. Then since there are no x cubed and x squared terms, since there is no x cubed term, then I'm going to write plus 0x cubed again, and then minus 3x squared. This is just for a clear arrangement, plus 2x. Now we subtract. X raised to the power 4 minus x raised to the power 4 is 0. 0x cubed minus 0x cubed is 0. 0x squared minus 3x squared is 3x squared. That's 0x squared plus 3x squared. And 3x minus plus 2x is the same as 3x minus 2x, which is x. And we'll bring down the next term, which is minus 1. X cubed in this x cubed doesn't divide 3x squared, so that's all. And then we write the fraction as x raised to the power 4 plus 3x minus 1 divided by x cubed minus 3x plus 2 is equal to quotient, which is x, plus the ratio remainder, which is 3x squared plus x minus 1 divided by divisor x cubed minus 3x plus 2. Now we can see that the fraction has been reduced to a quotient and a proper fraction. So we go ahead and split that proper fraction into partial fractions. So 3x squared plus x minus 1 divided by x cubed minus 3x plus 2 is equal to, I want to factorize. I'm factorizing the denominator first of all, which I already know is the same as x plus 2 times x minus 1 squared. So this is the same as 3x squared plus x minus 1 over x plus 2 times x minus 1 squared. Now, I'm splitting this into partial fractions. And that is a over x plus 2 plus x minus 1 squared is a repeated linear factor. So it will have two partial fractions, and that means b over x minus 1 plus c over x minus 1 squared. And this simply means, I think I want to write that for clarity, 3x squared plus x minus 1 divided by x plus 2 times x minus 1 squared. X plus 2 times x minus 1 squared. So the LCM of the denominators is x plus 2 times x minus 1 squared. Which is, so its the numerator of that fraction will be a times x minus 1 squared plus b times x plus 2 times x minus 1 plus c times x plus 2. A times x minus 1 squared plus b times x plus 2 times x minus 1 plus c times x plus 2. Since the denominators are the same, that means the numerators are also equivalent. And that means 3x squared plus x minus 1 is equal to a times x minus 1 squared plus b times x plus 2 times x minus 1 plus c times x plus 2. We can use the cover-up method here too. So putting x equals 1 in this identity, 3 times 1 squared plus 1 minus 1 equals a times 1 minus 1 squared plus b times 1 plus 2 times 1 minus 1 plus c times 1 plus 2. Now 1 minus 1 is 0. That means the whole of this is 0. 1 minus 1 is 0. That means the whole of this is also 0. Because 0 squared is 0 times a, that's still 0. So we are left with 3 plus 1 minus 1 equals 3c. And that means 4 minus 1, which is 3, equals 3c. Which means c is equal to 1. C equals 1. So what else can I put in that identity? What can I put in that identity to get the value of another constant? Putting x equals minus 2. 3 times minus 2 squared plus 1 minus 1 is equal to a times minus 2 minus 1 squared plus b times minus 2 plus 2 times minus 2 minus 1 plus c times minus 2 plus 2. So minus 2 plus 2 is 0. That means the whole of this is 0. Minus 2 plus 2 is 0. That means the whole of this is also 0. So we are left with minus 2 squared is 4. 4 times 3, 12. 12 plus 1 minus 1 equals minus 3 squared is 9 equals 9a. And that means 13 minus 1, which is 12, equals 9a, which means a equals 12 over 9, which is 4 over 3. That means a equals 4 over 3. I'm going to be sure that's correct. Okay, let me go over that again. Putting x equals minus 2. 3 into minus 2 squared plus 1 minus 1. Oh, sorry. Putting x equals minus 2. That should be 3 times minus 2 squared plus 2, because x is 2 here, minus 1. And that's going to be, let me raise this first of all. That's going to be 12 plus 2. 12 plus 2 minus 1, which is 3x squared plus x minus 1. That's correct, yes. 3x squared plus x minus 1. And that's 3 times minus 2 squared plus 2 minus 1 equals 8 times minus 2 minus 1. B times minus 2 plus 2 times minus 2 minus 1 plus c times minus 2 plus 2. So this is minus 2 squared is 4. 4 times 3 is 12. 12 plus 2 minus 1 equals minus 3 squared is 9. 9a. And this becomes 12 plus 2 is 14. 14 minus 1 is 13. Is that what I'm supposed to get? One second. I need to be sure that I'm doing the right thing. C over x minus 1 squared. Putting x equals 1. 1 minus 1. 3x squared. Minus 2 squared. That's 4 now. Times 3, 12 plus. Oh, x is minus 2. You can see how easy it is to make mistakes here if one is not careful. I think I should just rewrite this left-hand side. Putting x equals minus 2. It should be 3 times minus 2 squared plus minus 2. X is minus 2 minus 1. So that means the left-hand side will be 12 minus 2 minus 1. And the right-hand side will be 9a. So that means 9 equals 12 minus 2 is 10. 10 minus 1 is 9. 9 equals 9a, which means a equals 1. Sorry about that error. So that mistake, a is equal to 1. Now what else do we put in the identity to obtain another constant? Okay, which is the last constant, and that's b. It doesn't seem like there's any other value we can put to obtain in one stretch b. But we can just put any value to reduce the identity into a simpler equation, and we substitute the values of C and A to obtain B. So let me just put x equals 0. Putting x equals 0. Putting x equals 0, 3 times 0 squared plus 0 minus 1. 3 times 0 squared plus 0 minus 1 is equal to A times 0 minus 1 squared plus B times 0 plus 2 times 0 minus 1 plus C times 0 plus 2. And that means minus 1 equals A minus 2B plus 2C. So we substitute the values of A and C, which means minus 1 equals 1 minus 2B plus 2 times 1, because C is equal to 1. And that simply means minus 1 equals 1 minus 2B plus 2. And that means 2B equals 1 plus 2 is 3. And when you take this minus 1 to the right hand side, it becomes plus 1. What I did was bringing minus 2 to the left hand side and taking minus 1 on the left hand side to the right hand side. So that means 2b equals 3 plus 1, which means 2b equals 4. And this means b equals 2. So we have all the constants. And we can now write the partial fractions into which the original compound fraction is split. X raised to the power 4 plus 3x minus 1 divided by x plus 2 times x minus 1 squared is equal to, when we divided the numerator by the denominator, what we got was x plus, I love to always write that, x plus 3x squared. I think I should just do this. There's a way to copy that. Okay. I really want to copy that and see how beautiful that works, how beautifully that works. Yeah. Can I remember how to do that? Oh, I don't think I can remember. Alright, I think we should just move on. Let me just write it. X plus 3x squared plus, I should be able to do that. Oh, I have to select the scissors before I light in what I want to cut. Duplicate. Let me just copy and bring it here. Let me put it here. Paste. Okay, that's good. And I can delete what I had there before. That looks a bit cheeky. I really want to do that. I'm trying that again. It's possible to just copy and paste what I had here. Oh, I haven't selected. I think I'm doing it right now. There you go. Copy. Now come and paste it here. Paste. Oh, I didn't paste that properly. Oh, that's beautiful. That's how to paste it. So this this is what we get when we divide the numerator by the denominator, and that becomes x plus this proper fraction was split into I didn't even write I did not even write out what I split the proper fraction into. So what this means is, since I have a, b, and c, it means 3x squared 3x squared plus x minus 1 over x plus 2 times x minus 1 squared. 3x squared plus x minus 1 over x plus 2 times x minus 1 squared is equal to a, which is 1, over x plus 2 plus b, which is 2, over x minus 1 plus c, which is also 1, over x minus 1 squared. Therefore, so the original compound fraction, which is x raised to the power 4 plus 3x minus 1 divided by x plus 2 times x minus 1 squared, which gave me x plus 3x squared plus x minus 1 over x plus 2 times x minus 1 squared. This was what I obtained when I divided the numerator by the denominator, and the final answer will be x plus the result of the the partial fractions into which the proper fraction has been split. So that's x plus 1 over x plus 2 plus 2 over x minus 1 plus 1 over x minus 1 squared, which is the final answer. So when you divide the numerator by the denominator, you're going to get a quotient, which is going to be a very simple algebraic expression and a proper fraction. Then you resolve that proper fraction into partial fractions and add it to the quotient, which gives the partial fractions into which the original compound fraction is resolved. So it's as simple as that. You only has to be very, very careful not to make mistakes with the, not to make mistakes finding the values of a constant when you are resolving into partial fractions. So let's see, what's Roman figure 3? Roman figure 3, let's see that. Roman figure 3. I'm actually going to do the copying thing here. Roman figure 3, that's Okay, 2x is about 4 minus 17x minus 1 over x minus 2 times x plus 2, sorry, x squared plus 5. I'm copying that. Let me copy that and bring it down here. I'm pasting it here. All right, beautiful. So that's it. After copying, you still need to position it properly. I'm doing that again. Just learning new tricks with this pen. Roman figure 3. Yeah, that's it. Copy and paste here. So, and that's it. 2x raised by 4 minus 17x minus 1 over x minus 2 times x squared plus 5. If you split the denominator, you'd see that the fraction is an improper fraction. I'm going to split the denominator because I need it to I need it for my I need it to divide. I need it for my division. So let's say that x minus 2 times x squared plus 5 is going to be x cubed plus 5x minus 2x squared minus 10. X cubed plus 5x minus 2x squared minus 10. So that means this fraction is the same as 2x is power 4 minus 17x minus 1 divided by x minus 2 times x squared plus 5. So it's obviously it's clearly, I want to write this as x cubed minus 2x squared plus 5x minus 10, which is clearly an improper fraction because we can see that the degree of the numerator is greater than that of the denominator. So the next thing is to divide the numerator by the denominator, which is, what do I have when I do that? So x is power 4. There's no x cubed term, so I'm going to write plus 0x cubed. No x squared term, so I'm writing plus 0x squared minus 17x minus 1 divided by x cubed minus 2x squared plus 5x minus 10. So 2x is power 4 divided by x cubed is 2x, and that means 2x is power 4. There's no x cubed term, so I'm just going to fill 2x is power 4. I'm just going to fill this with 0. No, 2x is power 4. So x is power 4 minus 4x cubed plus 10x squared minus 20x. I think it's quite easy, except that one has to be very, very careful when evaluating and doing all these simple things. 2x is power 4 minus 4x cubed plus 10x squared minus 20x. When we subtract, 2x raised to the power 4 minus 2x to the power 4 is 0. 0x cubed minus 4x cubed is 0x cubed plus 4x cubed, which is 4x cubed. 0x squared minus plus 10x squared is 0x squared minus 10x squared, and that's minus 10x squared. Now, minus 17x minus 20x is the same as minus 17x plus 20x, which is 3x plus 3x. And we'll bring down the next term, which is minus 1. So we divide again. 4x cubed divided by x cubed is 4. So that's 4, and we multiply as usual. 4x cubed minus 8x squared plus 20x minus 40. So we subtract. 4x cubed minus 4x cubed is 0. Minus 10x squared minus 8x squared is the same as minus 10x squared plus 8x squared, which is minus 2x squared. 3x minus plus 20x. 3x minus plus 20x is the same as 3x minus 20x, which is minus 17x. And minus 1 minus 40 is the same as minus 1 plus 40, which is plus 39. Which is plus 39. So we can divide further, and that means the fraction 2x to the power 4 2x to the power 4 minus 17x minus 1 divided by x to the power 3 minus 2x squared plus 5x minus 10 is the same as usual. We write the quotient 2x plus 4 plus a fraction, which is the ratio remainder to divisor. And in this case, I'm writing it as 39, just not to write a negative value first. 39 minus 2x squared minus 17x divided by x cubed minus 2x squared plus 5x minus 10. Now, this fraction is a proper fraction, and that's what we now need to split into partial fractions. So there we go. Three 39 minus 2x squared minus 17x divided by x cubed minus 2x squared plus 5x minus 10 is the same as, I know that this denominator x cubed minus 2x squared plus 5x minus 10 is the same as x minus 2 times x squared plus 5, because that was actually what I expanded to get x cubed minus 2x squared plus 5x minus 10. So the numerator remains what it is, 39 minus 2x squared minus 17x. So we proceed to the partial fractions, the LCM of D, and that's going to be equal to the x minus 2 is a linear factor, so its numerator will just be a plus x squared plus 5 is a non-repeated, is a non-linear, non-factorizable factor. So non-linear, non-factorizable quadratic factor. So its numerator will be bx plus c. It's going to be a linear expression. So that's bx plus c over x squared plus 5. And that means LCM of the denominators is still x minus 2 times x squared plus 5. And the denominator of that fraction is a times x squared plus 5 plus bx plus c times x minus 2. Which means 39 minus 2x squared minus 17x. 39 minus 2x squared minus 17x is equivalent to a times x squared plus 5 plus bx plus c times x minus 2. So what do we do? All right. I think I will just expand the right hand side. That will mean ax squared plus 5a. Ax squared plus 5a plus bx squared minus 2bx plus cx minus 2c. I want to collect like terms. That's ax squared plus bx squared. I'm collecting like terms on the right hand side. Plus bx squared minus 2bx plus cx plus 5a minus 2c. Let me check and be sure I didn't leave out, I didn't omit any of the terms. Ax squared plus bx squared minus 2bx plus cx plus 5a minus 2c. Alright, that's beautiful. And this simply means a plus b times x squared plus minus 2b plus c times x plus 5a minus 2c. Now comparing the coefficients of x squared, comparing the coefficients of x squared. What's the coefficient of x squared on the right hand side? It is a plus b. And on the left hand side it is minus 2. So that means a plus b is equivalent to minus 2. Let's call that equation 1. Now comparing the coefficients of x. The coefficient of x on the right hand side is minus 2b plus c. So we write minus 2b plus c. And on the left hand side it's minus 17. So that means minus 2b plus c is equivalent to minus 17. That's another equation. Let's call it equation 2. Now comparing the constant terms. Comparing the constant terms. Comparing the constant terms. The constant on the right hand side is minus 5a minus 2c. Beg your pardon. 5a minus 2c. 5a minus 2c. And on the left hand side it is 39. So that means 5a minus 2c is equivalent to 39. That's equation 3. So we now solve these equations to obtain the values of the constants a, b, and c. How do we go about that? Equation 1 is in terms of a and b. Equation 2 is in terms of b and c, and equation 3 is in terms of a and c. So what do I do? Okay. I can make a the subject of 1 and put it in c, and then solve the new equation simultaneously with b, because that new equation is going to be in terms of b and c. Let's see what that means. From 1, a is equal to minus 2 minus b. So let's put that a. Putting that a in equation 3. What do we have? Putting that a in equation 3. 5, wherever you see a in equation 3, you write minus 2 minus b. 5a, which means 5 times minus 2 minus b, minus 2c is equal to 39. And that means minus 10 minus 5b minus 2c is equal to 39. Which means minus 5b minus 2c is equal to 39 plus 10. And that's simply minus 5b minus 2c equals 49. That's equation 4. That's equation 4. So we now solve equations 2 and 4 simultaneously, solving, because we can see that equation 2 and 4 are in terms of b and c, solving 2 and 4 simultaneously. Solving 2 and 4 simultaneously. What's equation 2? Equation 2 is minus 2b plus c equals minus 17. Equals minus 17. And equation 4 is minus 5b minus 2c equals 49. I'm checking equation 2 again to be sure. Minus 2b plus c equals minus 17. And equation 4 is minus 5b minus 2c equals 49. So what do we do? Let me multiply equation 2 by 2 and equation 4 by 1, just to make the coefficient, just to eliminate c. That means minus 4b plus 2c equals minus 34. And this remains minus 5b minus 2c equals 49. So to eliminate c, I need to add equation 4 to equation 2. Minus 4b minus 5b plus minus 5b is minus 9b. 2 plus 2c plus minus 2c is 0. That means minus 9b is equal to minus 34 plus 49 is minus 34 plus 49 is minus 15. No, minus 34 plus 49 is 15, and that means B equals minus 15 over 9, which is minus 5 over 3. That's minus 5 over 3. And so, okay, I already know that A is equal to minus 2 minus B. A equals minus 2 minus B. That means A is minus 2 minus 5 over 3, which means minus 2 plus 5 over 3. And that's minus 6, which is minus 1 over 3. Of course, this means which is the same as minus 6 over 3. Minus 6 over 3 is the same as minus 2. So minus 6 over 3 plus 5 over 3 is going to be minus 1 over 3. That's correct. So we now find, how do we find C? Putting A in, putting B in 2. Putting B in 2 and putting B in equation 2 to find C. Putting B in 2. What's equation 2? Minus 2B plus C equals minus 17. Minus 2B plus C equals minus 17. And that means C equals minus 17 plus 2B, which simply means minus 17 plus 2 times B. What is B? Minus 5 over 3. Minus 5 over 3. And that means minus 17 minus 10 over 3, which is minus 61 over 3. That's C. So the proper fraction that we obtained when we divided the numerator by the denominator can now be split into, what's that proper fraction? 39 minus 2x squared minus 17x over x minus 2 times x squared plus 5. So we can copy that here. So that means 39 minus 2x squared minus 17x over x minus 2 times x squared plus 5 is the same as A. What is A? Minus 1 over 3. Minus 1 over 3 divided by x minus 2 plus bx. What is b? B is minus 5 over 3 x plus c. That's minus 61 all over x squared plus 5. And that is equal to minus 1 over 3 times x minus 2 minus Okay, let me write it this way for clarity. This is the same as minus 5x minus into 5x plus 61 over this is the same as minus into 5x plus 61 over 3. Of course, b is 61 over 3 too. C rather is also 61 over 3. So that means over 3 into x squared plus 5. And finally, I can write this as minus 1 over 3 times x minus 2 minus 5x plus 61 over 3 times x squared plus 5. That's what the proper fraction obtained when the numerator of the original compound fraction was divided by its denominator split into. So therefore the original compound fraction which is 2x to the power 4 minus 17x minus 1 divided by x minus 2 times x squared plus 5 is equal to, let me see, what did I get? I'm going to what I got when I divided the numerator by the denominator. Okay, yes, is equal to 2x plus, I want to copy that, which is equal to this. This space, take it. I should just write it here. Which is equal to this. Yes, which is equal to this is the same as 2x plus 4 minus 1 over 3 times x minus 2 minus 5x plus 61 divided by 3 times x squared plus 5. And that's the final answer. It looks like something a bit too tricky, but it is certainly not. One only has to be very, very careful and make sure that all evaluations are correctly done, and that takes a lot of what's it called, a lot of accuracy. And you always get the correct answer if you can be careful enough. So that's it. Simply, we have gone through all of the types of partial fractions and how to go about them. So I hope you enjoyed the video. Please subscribe to this channel and do hit the like button so that you'll be notified as soon as another video is uploaded. Thank you very much. I love you and see you in the next video.